So first, let's start off with what we already know, as that is, we got a starting place, and we're trying to end up somewhere, right? And we have two ways of doing that. The way you originally learned, which is find out how far it is away horizontally and vertically, right? And that was the location or the coordinate of that point, just the horizontal and vertical distance. Now we have this new version that just says, well, how far is it from the starting point to the ending point? You know, as diagonal as you want, we call that the radius. And of course, to point to the right direction, we have to know what angle to move at. So that's another way to locate any point in space in 2 dimensions. Okay? So we're just getting better and better at seeing what the relationship is between these and how to convert from one to the other. Okay? So it's worth mentioning that polar has radius and theta only, and rectangular has x and y only. So when you're converting equations, you got to make sure your answer, like for rectangular, has only x's and y's, and polar only has r's and thetas. So you can't have answers that have some x's and some thetas or anything like that. It's got to be all the way one way or the other. Okay? And we saw that we have the relationship from trigonometry that actually connects these, right? So we know that the adjacent over the hypotenuse is known as cosine. And likewise, the rise over the hypotenuse is known as sine. So if we want to know what x actually equals and what y actually equals, we can multiply both sides by r for both of these. And then we'll have final conclusion that x is the same as whatever the radius is times the cosine of whatever theta is, and y is going to be r times the sine of theta. So when we're converting back and forth, right, this left side is going to be the rectangular, right, and this right side is going to be the polar. So we can go through, if we have, let's say, a rectangular equation, we could just replace each x and each y with r cosine theta, r sine theta, and that would work to convert it over. Now, there's another way of, there's another one we can use as well, and that's your good friend from the 7th grade, the fact that x squared plus y squared equals r squared, Pythagorean theorem. So we could always use that as well. And these are the main ones we want to stick to. So just 3 different, basically like identities that we're going to substitute in and out. Alright, so stick to that. And to a lesser degree, if by some chance if we just have like a single r, we could manipulate this and take the square root of both sides and just take the square root of r squared and get r. And then, of course, square root of the left side as well and get square root of x squared plus y squared. So that's possible as well. So those are your main go-tos as far as substituting in, right? So, and they're also listed down here. And then don't forget there's this other one as well. But this is like in case of emergency only. So if nothing else works, then use nothing else works, then go ahead and use this one. But that's not something you want to use unless you absolutely have to. Okay. All right, so let's practice a little bit. So when we're doing this, you got 2 steps. First, swap out all the x squareds, y squareds, y's, and x's for something that's polar. And then we got to simplify and get it r equals as much as possible. So first step, I could just identify, looking at this, here. Like I have right here, I have an x squared plus y squared, right? So of course, I can use this and substitute it up. So I'm just going to rewrite this with r squared. And then I have minus 6 And of course we have a y right there, which is r sine theta. So I can swap out or substitute r times sine of theta. Okay, so that's the first part. It's just now I have a new equation. Went from x's and y's only to r's and thetas only. Right, so step 1 completed. Step 2, let's get this equal to r only. Right, so we just want r equals as our final answer. Right, so we want to have this. So we got to do some algebra. Everything from here is just algebra. So how do you suppose we do that? Right, so if I had, forget all the trig, if I had just r squared minus 6r, what would I do to get r by itself or solve for r? What was that? Factor, yeah. Factor out an r, right? That's exactly what we would do. So do the same thing here. We got an r here and r here. Factor out an r. So yeah, just algebra. Don't overthink it. 6 times sine theta equals 0. Just like we did here. And then we usually broke this up into 2 parts. Like here, r equals 0, r minus 6 equals 0, and we solve them. So we'll do the same thing here. So this is called the multiplication zero product property. So basically, if you are multiplying 2 things together, 2 factors together, and your answer is 0, well, the only way to do that is if one or both of these are equal to 0. So that's why we're allowed to do this. And the way to interpret that is that in order to use this number has to be 0. If this is like a 1 or something, there's an infinite number of ways to multiply to 1, right? So what is this actually telling us? This is like another one of those instances of know what your answers mean. So this is saying one equation is r equals 0. Now what would the equation r equals 0 look like if you graphed it? Yeah, is it a circle? No, so we know r equals 0 is not going to be equivalent to this thing if we graph both of them, right? So this is what they call a trivial solution, where we get it, but a circle with radius of 0, yeah, technically you get an answer of 0, but it just doesn't make sense and we don't pay attention to it. So that's why we could like to do the factoring. It removes this trivial solution and we're left with something that actually is useful. So the remaining, we can actually solve for this, right? We can add the 6 sine theta and accomplish our goal of having r equals. So first goal was removing all the x's and y's, replacing with r's and thetas. Second goal, using algebra, get r equals. Now, the result, I mean, if you look at the equation compared to what we started with and what we ended up with, yeah, the answer is much simpler. And this is why we really like polar, especially when we get into different types of equations that we have to take the derivative of and integrate with. In calculus, this is much easier to work with than a big equation with 2 variables like this one. So it's kind of the payoff is going to be down the road, but I promise it's worth it. Okay. So that's the basics of it, right? 2-step process. No problem. All right. So this is a circle. This happens to be a circle. It could be any shape though, and you're going to see shapes you've never seen before when you check your answers. So that's the next thing you want to do is, since it's all very new to you, you definitely want to check your answers, right? So you want to go over to Desmos. You want to type everything in, use the app on your phone or whatever it might be, but you want to verify what you're doing is actually correct. And take your answer. R equals, was it 6 sine of theta? And you can see since the graphs overlap, you know these equations are equivalent. Just like that. And you'll notice that here and here, the diameter is 6. That happens to correspond to that 6. So if I made that 4, you notice the diameter is 4. And 6. And you'll notice that it's sine and it's on the y-axis. It's always the vertical axis. So what do you suppose happens if I change this to cosine? Now it's on the the run, right? Cosine goes with run, goes with x-axis. So there are some patterns here, and as you practice this, you kind of get used to it, and you get faster at it without doing a whole lot of extra work. So you'll be using Desmos a lot to verify your answer, especially when we get to things that are something you've never seen before, which is pretty cool. All right, so let's try another one. Which we got here is a parabola. All right, so ordinarily, oh, not ordinarily, always, this is a parabola, like that. So how do we write that in the polar? So same idea, right? So we have things to substitute. We have y right there, and then we have now an x right there. So we can substitute those two and see what we get. So go ahead and do that. Simplify maybe a little bit. And your algebra is going to be really important here. So I'm squaring r cosine theta. So what happens if I square r cosine theta? What do I get? And then you say, is it r cosine squared theta? Is that correct or not? No. Good. So we have to square everything in here. Remember, this just means r cosine theta times r cosine theta, right? So we have to have r squared and cosine theta squared. We have to have both. So the little details in the algebra will make a difference. Okay. So what do we suppose we should do next to get this to be r equals? We have only r's and thetas, so what's next? Now, what did we do last time? It's equal to 0. We factored. So let's try that out. You know a technique that already worked. Try it again. See if it works. Only difference is it's not equal to 0. So get it equal to 0. All right. So I'm going to subtract that r sine theta to both sides. All right. So it is equal to 0. And now it basically looks like the first example, right? We could factor out an r, we could do some solving, so go ahead and do that. So while it's not the same type of equation, the answer will look different. The steps are the same. So do the same steps, see what you get. Factor the r out, solve for r. Of course, we're trying to get r by itself, so we could take this minus sine theta, put it back over here, and then just divide by everything Except what we're solving for. We're trying to solve for r, so you leave that alone. Divide by the 2, and divide by that cosine squared theta. That's gone. That's gone. And we have our final answer. Alright. There we go. And let's double check this. So we'll have as a parabola, right? Y equals 2x squared. There we go. And our answer was y equals sine theta all over, we got 2 cosine theta and squared. Whoa. It's what? Cosine squared theta. So making a point here that, yeah, details matter, right? If I put this in the wrong place, or I could just do, you know, cosine theta squared like this, and then it's fine. Or I could do, like we did on our page, we put the squared on the cosine, not on the theta. So you can see it's a different answer if you're squaring the cosine or you're squaring just the angle. So if I do it this way and square that only, same thing, now it works fine, right? So details matter. Since these graphs are new to you, definitely use decimals to check your answers, because things might look perfect, and then, you know, if it's checked, you're like, oh, wait a minute, something's way off. I didn't, you know, it's probably a little thing. You saw how crazy that was with one detail not correct. So don't freak out if it looks like completely off. It's probably just one little small thing. All right, so back to where we were. So this is converting the rectangular to polar, right? Definitely mostly algebra, a little bit of substitution. So next, let's look at the reverse. So kind of do this in the reverse. Start off with the polar and try to get an answer with only x's and y's. So slightly different algebra. You know, since we like factored out an r and disappeared, we're going to use a technique that actually puts an r back in there, because that will lead us to get an r squared, which will let us substitute in x squared plus y squared. So if we don't have an r squared, we want to do something to get an r squared. And there's several ways of doing that. So for instance, right here, right, we have r equals 3, and from before we already know that r equals 3 is a circle with a radius of 3, right? It's all the points, regardless of the angle, just all the, you know, infinite number of points that are a radius of 3 from the origin, right? So but we can't just substitute r, and we want to avoid doing the square root if we can, right? So if we know we want an r right here, it's okay to do a little work on this ahead of time. So I can multiply both sides by r right here, right? And that way it gives me r squared equals 3r. Now that's one thing you could do and then substitute it, but then the r doesn't really help us. Like, what am I going to do? I'll just have, you know, an extra r, and, you know, we're trying to avoid using just r. So what's another way I could get an r squared? Yeah, I can just square both sides, right? And that way I get r squared equals 9, and I don't have an additional r to worry about and think about. So it might take a little, like, well, if I do this, I won't be able to substitute for that, so maybe try something else, right? It takes a little planning. And now we could take that r squared, which we know is the same as x squared plus y squared, and that equals 9, right? Which you guys already know, that's the equation of a circle with a radius of 3, because the 9 is the same as 3 squared. Right? So sometimes, yeah, just squaring both sides will work just fine. If there's a number on the right-hand side, squaring both sides works really good. Okay. Now, something like b, we could try squaring both sides because I want that to be squared. But if I go through and square this, that's not really going to help me much because what I'm missing right now is I need an r right here, right? That's what's missing, is that up here, right, I need to substitute in for x, I need to have an r cosine. And if I just do what I did on the last problem, squaring this doesn't make this an r cosine, so squaring is not a good strategy here. So here's the other side of it, where multiplying both sides by r will be a good thing, because I get the r squared that I'm looking for on the left, and then when I distribute on the right, I get 5r plus r cosine theta. So now I can replace that. All right, so you kind of got to look at, well, what you're doing. Does that lead to easy substitutions, or is it just making things worse and not getting anywhere? So for both of these, we can substitute. So we have, once again, r squared, right? Replacing that with the rise and the run, x squared plus y squared. And then this right here, r cosine theta, is just x. And then we did everything we could, really, because those are only two options at this point. So here's a situation where we just have an r left over, and we have to use that one that we don't really like, which is x squared plus y squared, all underneath the square root. So in this case, once again, you can see how complicated the rectangular version is. And when you start doing calculus, to start working with this and maybe try to take an integral of it is ugly. It's just almost impossible, right? But 5 plus cosine theta, super simple to work with, right? So this is just really showing you why we want to stick with polar for something a little bit more simple, because the rectangular version is just super ugly. And then once again, go through and check it. Okay, so this is going to be r equals 5 plus cosine theta. There we go. So it looks like a circle, right? Just looks like a circle with maybe centered at 0, 1. So it's interesting that, I don't know if this is right or not. Let me see here. And it looks like it has a radius of 5. So how come I didn't get this as the answer right here? All right, so the question is, we got this big old long answer, right? And I'm seeing that this equation works just fine. How come it appears to be true? Because that's not the answer we got, right? So, fair warning when you're checking your answers. When you're checking your answers, you might need to zoom in. And if you do that, you'll see that, yeah, while it appears that these are the same circle, they possibly could be very close but not real. So then when you check the answer we really got, that's more complicated. Square root. What? X squared plus y squared equals x. And look at that answer, and you can see those are indeed the same thing, right? So we do need this more complicated answer, it turns out. Okay. So keep on checking, and you're going to see some answers like you saw when I misplaced the squared. you're going to see some graphs that you've never seen before. There's a whole set of graphs that are possible with polar coordinates that are not anywhere else. So not everything's going to be a circle. Do not assume that. We had parabolas. You have parabolas that are on their side, not open up and down, but open left and right. You can have all sorts of graphs. So as long as the graph, whatever shape it is, matches, you're in good shape. Okay. All right. So let's go ahead and do this last one. So we had two examples, right? One was we squared both sides. That helped us. This one we multiplied both sides by r, and that helped us here. So what should we do here, looking at this? Should we square both sides or multiply both sides by r? Right, it's kind of like the trig identities, and you have to substitute correctly. So you're looking at sine. There's a sine there, right? However, I need an r there as well. I can't just have a sine and substitute. So that's a key that if you see that, then you know you need to multiply by r on both sides. Right? So I'll get the r squared, which I can substitute on the left, and on the right I'll get 4 times r sine of theta. So now I can substitute both of those, the r squared and the r sine theta, and I'll have only x's and y's. So every sine, every cosine needs a radius to go with it. So if you have like a bunch of stuff on the right hand side, you might need to multiply by a bunch of r's if there aren't any. Right? So that every single sine and cosine has its own r to go with it. So now we got x squared plus y squared equals 4 times r sine theta. Just think of sine and y, they're synonymous with one another, so don't mix those up. And for now, we could leave our answer like this. Just recall back in December when we did conic sections, if we were actually going to graph this, it'd be a lot more work. We'd have to get this equal to 0 and complete the square, right? And see, well, half of this number is -2. Square that, you get 4. Add that to both sides, and then we can write this as x squared plus y minus 2 squared equals 4. So this does tie in what we've done before. You don't really need to do this part, but just showing you that some of this we have seen, but those are going to be equivalent as well as these are equivalent. Okay, so this one could be our final answer for now. Just use decimals to verify everything, and it is possible to get different answers or different looking answers, and they're actually the same graph. So if your answers don't match somebody else, let decimals decide who is right and wrong. Okay. All right, so that's about it.